John's coming.
Okay. Okay, we will kick off, folks. I know there's some more folks to join us, but thank you. Welcome. Good morning. I think it's morning for everyone on there. If you're from New Zealand, it's slightly later in the morning for you. But thanks for joining us this morning. We're super excited to have you with us. As well, we're also super excited to have our speaker with us, who is coming all the way from Philadelphia in the US, just before Thanksgiving. So thank you for making the time, Joel, to be with us. He was just telling me earlier he's got an easy one. He's going to someone's house for Thanksgiving, so it's easy. Just needs to find a turkey, find one in the woods, and then we will be off and running round to to dinner. Joel Levitt is a guru based in the US who we've been trying to work with for many years. He has forgotten more than most know about this area, and he's basically 35, I think 35 years, Joel, I don't believe it. You can't be that old, but over 35 years in this maintenance and reliability space. He's written 13 maintenance management texts and chapters, and he's just so well renowned in the US. And there's, I think you were telling me you've been to Australia quite a number of times as well. But we are so pleased to have you with us and to talk about something which is pretty new and certainly very, very relevant to the group. So over to you, Joel. Welcome. Thanks a lot.
Thanks very much, Ian. Just make a sign with your hand if you can't hear me, because I got a little bit of a cold. And if I start coughing, I'll try to mute in time so you don't have to listen to it. So I got interested in this derailment in Palestine, Ohio, in February, because years ago I worked for Conrail, which was the freight carrier, the government-owned freight carrier, and they ended up splitting up the company and selling half of it to Norfolk Southern and half of it to CSX. So, I kind of felt like I kind of knew what was going on a little bit with this. I worked on the maintenance of the way, which is the track. I worked on a train that we ground the rail profile to meet the wheels of the cars, and there was a lot of complaints about the lack of maintenance. So when this train derailed, I kind of thought, oh, I know what's going on. You know how I had a little bit of contact with it 20 years ago, and now I'm an expert. You know how that goes. So I started to look into this, and the first thing I noticed is it was hard to look into because everybody seemed to repeat everybody else's stories, and nobody was looking at it deeply. Um, so it was kind of a little crazy. So let me just get started with. I want to go through what actually happened, and then why it happened, and then talk a little bit about what happens corporately, to facilitate. If I say it exactly, it'll be facilitate crap like this. Um, I don't think that there was bad people involved. I think there were. Um, they had set up goals that didn't make any sense given the reality of what the business that they were in. So it's been a long time. I say 35 years, but I think I wrote that a little while ago. I think 1987 was when I gave my first class, but I was involved in maintenance when I got out of high school and worked aboard a ship in the engine room. And I hate to tell you this, guys, but I learned that I'm not a natural person for actually working. I'm a more natural person to sit and chat and have a couple beers. I'm not so natural at, really working hard. So um, my father got me the berth on the ship. It's hard to get a berth on a merchant marine ship, and I think he did it because he wanted to be absolutely sure that I went to college. Because after that summer on the ship, I went directly to college because 100 degrees in the engine room, it didn't work for me. So I've spent a good deal of time in Australia. I would come for maybe 3 or 4 weeks every year for maybe 10 or 12 years. So I've gotten to see the capitals, and I've gotten to do a little bit of sightseeing and stuff like that. My goal, I was talking about this. I want to take that train that goes from Adelaide to Darwin. Um, I just think that would be really cool. So we're going to discuss this February 3rd catastrophe and some of the causes that we're going to think about are the fact that they were using obsolete tank cars and inaccurate application of predictive maintenance technology. Um, they also changed the way that they schedule trains, and this is something that's happened all over the world. Um, and they're using much larger trains than they had, and they actually don't have yards that are big enough to build a train the way properly with making sure the heavy stuff is in the front. And they've redesigned their systems so that they don't do maintenance. Um, well, that's my conclusion. They don't do maintenance. So we'll look into the whys of this. But I want to be clear about this. I'm not a railroader, so I don't know the deep stuff about railroading and maintenance of the way and all that stuff. I'm also not a regulator. So, there's a lot of talk about the way railroads in the United States are regulated. So I'm not that. And I'm also not in a community that suffered from um, the derailments that are happening pretty regularly. And I'm certainly not a first responder. So all those groups have very different points of view about what happened and how it went. Um, I'm like a maintenance guy, so I'm going to be looking at it from maintenance eyes. So, all the realities of the railroad um, are fine, but I'm going to be really concentrating. We're going to be talking about the uh, maintenance aspects of this. This is not about Norfolk Southern. So I'll show you some other railroads, but it's about managing assets, like big assets for a long life, for safety and for, not destroying the environment and stuff like that. So um, this is a very tough thing for corporations that are supposed to make a profit. This is really tough for them to get their brain around it because it's so easy. You guys know this. I would assume it's so easy to defund maintenance for a little while, and you'll see no consequences for a decent amount of time if you've been doing your job. So if it's a tough um, market, like right now, some markets are really tough and you need to cut back on maintenance, they'll do that without even thinking about it. But so this is not about Norfolk Southern. I don't think they're substantially different than any other company in this, in this line of work. So this is after 3 weeks of cleanup. Those are the tank cars that caught fire. Um, they right now, or if I say last month, they were out of pocket $1 billion for this little incident, and there's lawsuits wending their way through the courts, and there's still more money involved. But right now they're at $1 billion. So some facts. This is a small town in Ohio with about 4,800 people. I'm in Pennsylvania, which is East Coast. I'm in the eastern end of the state. This is just beyond the western border of Pennsylvania in Ohio. This is a very busy rail route. Like during the days, trains pass about every 7 minutes. I mean, railroad is really a big part of their situation. The train was 32N. It was 1.7 miles long. Um, I'm sorry, I should have converted that to kilometers because I know it's more kilometers. That's all I can tell you. It was 17,900 tons. So we have an asset that's, 1.7 miles long, 18,000 tons. It's being pulled by 3 locomotives, 2 at the front and 1 in the middle. There's 159 cars. 20 of them were hazardous, had hazardous materials. It was 10 degrees Fahrenheit, so that's pretty cold. The call came in that an eastbound train, so it was coming towards Pennsylvania, derailed with 38 cars derailing, and 11 of the 20 hazardous material cars caught fire. And they ignited 12 other cars. So there was, 23 cars that were on fire. This happened in the early evening. It was cold out. Now, the train's engineer had complained about the length of the train. And I'll get into this a little further, but the issue is when you have a train that long and you want to add cars to it, see, the way they do it now is they move the trains around and they add or subtract cars so that, they can keep the trains rolling continuously. But you can imagine it's easiest to add cars to the front of the train because you can pull the locos forward and insert the cars and then recouple it. So it's hard to break a train in the middle because there's no place to put the 2 ends. So that's like just a little fact, so that these long trains are very difficult to handle because if you put empty cars in the front of the train becomes intrinsically unbalanced and hard to handle because the heavier cars in the back are pushing on the cars in the front, and it's much easier to derail them under that kind of loading. Now, the train followed all the rules of train movement. So when I looked into this, they were traveling below the speed that they were limited. So they were limited to 50 miles per hour. They were going 47 miles per hour. All the train movements were authorized by, the lights, wayside signals, and cab signals. And the train was under what's called positive train control, which was run out of Norfolk Southern's Cleveland office. It was enabled and it was operating at the time of the derailment. So we're not talking about somebody that was like speeding. We've had some accidents here where people were texting, while they were driving the train. None of that. This train was being operated correctly under the rules that they were supposed to operate under. This is a typical Norfolk Southern loco. They're it's a GE unit. and they were refurbishing, in the process of refurbishing their locomotives for more efficient AC motive power. Now, it took a couple of days for this catastrophe to actually unfold. Um, it took 2 days to get the fire out. Um, 5 derailed DOT 105 cars, which I'll talk about, um, were concerning because they had vinyl chloride in them. And I'm not a chemist, but the way it sounded like when vinyl chloride starts to polymerize, it's an exothermic reaction. In other words, it gives off a great deal of heat and could be an explosion hazard. The reports were that the temperature inside one tank car was still rising after they put out the fire, and that's what concerned them. I say that with an asterisk because there were people, first responders, that didn't agree with that said that no temperature was rising after they put the fire out. But I can imagine in a big accident like this where there's hundreds of first responders, there'll be different opinions about what actually happened. So what they did was they vented the vinyl chloride to the atmosphere. So this caused a real big release of chemicals, but it did mitigate the possibility of an explosion, which would have been worse, according to the first responders that were responsible for this. So they made it was like 2 bad choices: run the risk of an explosion, or um, have the absolute risk of a discharge of hazardous materials in the air. This is a drone footage of the situation after the fire was put out. Looks like there's still a little bit of stuff burning. But you can see there's, to the upper right, there's, businesses. This passes near some parks, like playground type parks. It passes within, I think, no more than 8 or 10 meters of people's houses. At this place right here, they didn't have that situation. But as you'll see, this could have happened literally anywhere. It wasn't, it was a random occurrence that took miles to unfold. So just to, talk about why trains derail, the most common thing is that there's a problem with the rail itself. That was what I thought it was going to be. Um, if the rail spread a little bit, or um, the ties get rotten and they twist, train will go off the tracks. Axle box failures are not super common, but this is what happened here. We had the axle box failed. There could be also a fault in track geometry. Um, I was always interested, why on a smooth track does the train go clunk, 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 if you've ever been on a train. And apparently there's a certain amount of hunting, a vertical bounce, that the track will shift a little bit under the wheels. So it's like a really subtle thing, but there's certain conditions that make it worse, and that sometimes you can derail from that. Improper operation, obviously, collisions with things, obviously, and then train handling, where we have excessive speed. This is a general look at why trains derail. Now, derailments are pretty common in the States. In the last 10 months, or the first 10 months of 2023, there was 1,000 derailments. So just get a sense of that. But 40 of them were major events where there was the cars split open, stuff came out, fires and stuff like that. So we have a system where these 40 events are, multi-million dollar or billion-dollar events. And then there's 1,000 small events. Um, and you can see it's pretty well distributed all across the country. Um, so there's no place that's really immune from this. So I'm going to look at the first thing that NTSB, that's our National Transportation Safety Board, what they found, there was a huge, massive derailment in 2013 in Quebec that killed 47 people. This was just a terrible tragedy. And that train was was a railroad pipeline for crude oil. So it was all crude oil cars. And they were using this DOT 111 cars, and I'll talk about that. But after the investigation of this horrific accident, the Department of Transportation required the old cars to be replaced when they're carrying hazardous loads. Obviously, if you're carrying molasses, it's not going to be, as big a problem as if it's gasoline. So they wanted to phase out the DOT 111s and the DOT 105s, which were kind of an upgrade to the 111s, but still not fully safe. The cars that had the vinyl chloride were DOT 105s. They were better than the 111s, but not up to the new specs. And the Federal Railroad people said that, the companies had these cars in the books where they would last for 50 years and depreciation was that long. And so they didn't want to take these cars out of service because they were only 35 years old or 20 years old or 40 years old. They wanted to, so they were moving like at a snail's pace. Now, this is the car that was the problem. You can see there's places where the shields are prone to being punctured by the coupling of the car in front of them. Remember, there's 30,000 gallons or 107 or 8,000 liters of volatile material. The sill, which connects the tank to the wheels, is light, so it could fail. The valves on the bottom of the car are not protected, so they could, hit something and burst. The steel shell of the car is less than a half-inch thick. So there's some, issues. Now, it's a reliable car for moving non-hazardous materials, that it doesn't, if it derails, it doesn't matter because, if you lose vegetable oil, it's going to be a mess, but it's not going to probably be a disaster. So the 111s had thin shells. They're not required to have shields to protect the tank car from an adjacent car. The fittings and valves are not protected, and they don't have a pressure relief device sized to protect against a rupture in the case of a fire. So, the whole thing with pressure release valves is you calculate the worst case in we do pounds per square inch, and then you size the valve to do that, and it was not sized for that. The 105s were basically the same car, but they had some safety features added in. And the 117s are the ones that presumably in a derailment like the one that happened, they would have survived it without rupturing, and that would have been less of a catastrophe. And you can see this new car has thermal protection. It's got heat shields. All the different places are protected with crash boxes, and they're over a half-inch thick, so they're quite a bit thicker than the old 111s. Now, the 111s are still the largest component of the fleet of rail cars carrying Class 3 flammable liquids. So you have a really fun situation here if you're a student of government. The regulator for the railroads is the American Railroad Association, which is run by the railroads. So you kind of have a situation where there's different groups that regulate, but the main regulator is a company, is an organization of railroads. Now that would be kind of a conflict of interest, maybe. The second thing that happened, we have some, the bearings are designed to take a certain amount of heat, and they've installed temperature measurement, infrared temperature measurement along the rail track about every 20 miles. So this, it's called a hot box detector. So they're positioned to see the bearings and see what their temperature is. Between 170 Fahrenheit and 200 over ambient is considered non-critical, and you stop when it's convenient and inspect them. You also don't want the bearings to be greatly different temperatures. So if there's more than 115-degree difference on the same axle, that would be a problem. But greater than 200 is a critical measurement, and the immediate action is the rail car is removed from service, train is stopped. So just keep that in mind. 200 degrees is the critical number. So at milepost 49.81, the critical alarm instructed the crew to slow down and stop the train. The wayside defect detector, hotbox, issued the critical alarm. And here were the actual temperatures of the car that was the problem, car 23. At 79 mile marker, it was 38 degrees above ambient. Now from 79 to 69, it went up to 103 degrees above ambient. Now, any of you that do predictive maintenance would know that a trend, it's 10 miles. That's 10 miles, right? It's 10 miles. And we're looking at a 60-degree increase in temperature of a bearing. At 40 miles an hour, that's a 63-degree increase in about 15 minutes. So that would be kind of noticeable. At mile 49.81, where the derailment happened, it was running at 253 degrees Fahrenheit above ambient, exceeding the 200 degrees. And that's why they had to stop the train. So emergency protocols went into action. They happened immediately as soon as the alarm goes off in the locomotive. Engineer increased dynamic braking, and automatic emergency braking was also initiated. It takes a long time to stop a train, so it took a while. They looked back and saw smoke and fire and notified their dispatcher. You know, that was pretty far behind them. It's like a mile, 1.7 miles behind them. Dispatch, as well as the crew, called first responders. Dispatch told him to move the locomotives down the track a mile so that they'd be out of the way. They set the brakes on the leading cars and they moved the locomotives, and the first responders arrived. Now, in this particular catastrophe, no one died, which is kind of miraculous. It was a close call for some people, but nobody died on this. So this is what the hot box detectors look like. So they're located inboard and outboard of the track on both sides, and they're picking up the four bearings. Um, they use an infrared sensing. As far back as 2019, there was many investigations into whether they were looking at the right area of the bearing. So there's been a continual discussion about the efficacy of the hotbox detectors. We'll see. We'll evaluate this for ourselves. Now, at 69.1 mileage, that's 20 miles behind where the derailment happened. Car 23 was at 103 degrees above ambient. Okay, but there was a video taken by a store's security camera that showed flames coming out of car 23 at that milepost. The video was taken from a building security camera, and you can't really, I mean, in this picture of it, but you can see those like flashes at the bottom. So 20 miles before the derailment, fire was coming out of the bearings. And the hotbox detector only detected 103 degrees above ambient. So you just think about that. I think that's relatively good evidence that the hotbox detectors are pointing at something else. So this is what happens when your predictive technology reports something different from reality. If people get really hooked up on, oh, my reading says this, or this happens, or, my vibration is this. And part of that process should be to look at the facts and test it and validate it. Now, I do a lot of predictive maintenance training, and I've never seen anything quite as bad as this as far as being, out of the box. So part of the rail car's wheel set came off, leading to the derailment. They found the wheel set 100 feet from the point of the derailment with extensive thermal damage. Now, a Norfolk Southern employee at a monitoring center in Atlanta did not see the initial alert. In other words, when it went from 38 degrees to 100 something degrees, that alert, that difference should have, somebody should have intervened. They didn't see that the bearing was heating up. Now, that was in a earlier version of the article in the New York Times. In a later version, it turns out he was at home, not in the monitoring center. So I don't want to indict somebody that I don't know what they were looking at or doing or anything like that. But they're counting on these hotbox detectors, and the people that are overseeing them are not even in their dispatch center. Now, those bearing sets are supposed to be good for 2 million miles. And these rail cars had complaints about the bearings that were unaddressed. This bogie assembly is what we're looking at. Now, the thing that struck me about this is, I'm used to, manufacturing of cars and even like steel mills, refineries, but trains are heavy steel things. Like the shafts are good size, and there's a lot of steel that would keep this wheel set underneath the train. If I'm saying this so you can understand it, it's all structured together. It's pretty robust. Everything is heavy. there's guidance systems, dampers, steering, as well as electrical stuff and sensors. So all this stuff is in there, and when you see what happened, you kind of get a sense that this was not a good situation. So this is a broken axle of the typical type. It's not the one from uh, Palestine, Ohio, because I could not. They didn't put those pictures out where we could see them. But this is the type of wheel set that it would have been. Severe thermal damage. So I have like two fundamental questions. Um, why did this happen? Like, what was the engineering behind this? And the same question, why did it happen, but in terms of governance and economics? Now, as of today, the NTSB did not publish their final report on this crash. So, what I'm going to talk about are my opinions about what happened. So, I'm perfectly okay to be wrong about this. And if you know more about this than I do, I would love to hear your, what you have to say. But the first thing I found was that rail car maintenance is the most complicated legal problem of anything I've ever run into. Because, like trucks and airplanes, they're on the road away from their depot, literally. There's 300,000 rail cars rolling in the US, but only 20% are owned by railroads. The rest are either owned by shippers or by leasing companies. Each of the leases is written differently. Now, just imagine this. You're walking down a train, like inspecting a train, and each car is under a different legal system about who's going to fix it if it's a problem. Um, the leases are written individually, like there's no accepted leasing companies, and they all write it themselves. So who maintains it, who inspects it, and who repairs it is different for each rail car. I remember when we put together a train, we do it without regard for who owns the cars. It's done to meet the schedule. Now, railcar owners and lessees forego the PM or CBM condition-based maintenance because of costs and logistics. And I thought this was such a great statistic. There's 450 rail car shops in the United States, and there's 300,000 cars. And a lot of the rail shops are like mom and pop operations, like they're not huge um, maintenance centers. So you have to choose a simple repair in the field. The cost is low. You send somebody out, you fix it, and you go on. To transport a car to a specialized shop and repair it, just getting the car there is expensive. You kind of just visualize what you'd have to do. You'd have to separate it out from a train that's 1.7 miles long, move the train apart, and then direct that car onto a siding, reattach the train back together again. Somebody's going to have to pay for all it. And then you have to transport it to the shop and then fix it. So they tend to do a lot of field repairs that are, what we would call temporary repairs, or, bubble gum and baling wire type repairs. That seems to be pretty standard. So I'm not going to look at those legal things. I'm just tell you, as a maintenance person, we need to have some kind of system so that we know what every car is. We need to know things about each car, like how much is used, what's in it, loading. We need to know the distance, the loading, and the chemistry of the stuff. One of the problems is that the chemistry of some of the stuff they were carrying on that train was caustic to the rail cars themselves. So when you carry stuff like that, you have to do a lot more inspections, which they didn't do. PM has to be driven by utilization the same way we would do it on a tractor trailer or an airplane. And it has to be done reliably so that you know where you are. Now, in something like this, condition-based maintenance would probably be the strategy I would pick if somebody came up with a set of sensors that were accurate and robust enough to put in a rail car, which is a kind of a nasty environment. But the corrective work, in other words, the work to correct the defects that are found by inspection, has to be done in a reasonable time, or else you just inspected it and then it'll fail. So now this is like kindergarten maintenance management. Know what's going on in your physical assets. Use simple strategies to find out what's going on and then fix stuff before it fails. This is like you covered this in the first hour of a maintenance management course. And all of you, I mean, if you're in the maintenance field, know what you have to do. You have to get a CMMS, that's a computerized maintenance management system. You've got to build master files for every rail car with the specifics for that car. You have to set up a way to capture mileage, loads, chemicals. You have to set up a PM program based on OEM recommendations and history. Okay, now, does anybody here not know what I'm talking about? I mean, this is something that, this is like everyday stuff. We also want to track where they are so services can be scheduled. So we do it with trucks. Trucks are GPS enabled, and we know where every single truck in our fleet is. Do the PM, do the planned component replacement, and do the inspection, and do the corrective items. I mean, that's what a maintenance person would say about this problem. But now I'm going to get back into some theory. I'll spend a minute or two on theory here. This is something called the PF curve. It's potential failure to functional failure curve. Now, what happens is the height of the curve on the y-axis is the health. So where it's flat means it's healthy and there's nothing wrong. And then the x-axis is time or utilization. So as time goes on, we have an event, which is X right here. The deterioration starts here because of something happened to the bearing that caused deterioration cascade to start, but it might be microscopic. In other words, literally, it could be a piece of hard dirt got between the bearing and the race. Something really little that you wouldn't be able to detect it. You actually have to wait until it deteriorates, till it gets to the P point, which is when it becomes a potential failure. That's the first time you can detect the deterioration. So that point A, now we're going into further deterioration. Point A is where I could use, I could listen to with ultrasound and I could detect when it's, chattering, or vibration analysis would identify it. And maybe B is a really skilled worker could detect the problem. And C is a security camera on a building like 100 yards away can detect it. It's like flames coming out of it. Now, F, this point F, this orange dot, is when the asset no longer fulfills its basic function. It's not failed yet. And then D is where the equipment has broken all the way down. Now, if you look at this curve, the flat part of the curve is the sweet spot. So to avoid failure, what you have to do is stay on the flat part of the curve. And to do that, you've got to eliminate the things that would cause deterioration to start. So this is a famous curve. And all we're trying to do is figure out what X is and then try to eliminate it before it causes this cascade to start. Because until the cascade starts, everything is fine. So how do we stay on the flat part? Now, again, to maintenance and reliability folks, this is not rocket science. This is not quantum computing or some weird thing. This is basic mechanics. There's three things to avoid bearing failure. One is properly tighten everything, properly lubricate everything, and keep the thing clean. The second thing is precision maintenance, where the initial torque and alignments are done to spec correctly. And timely corrective maintenance, that when you do find a problem, you fix it so that it doesn't turn into a catastrophe. So you do these three things, and that avoids the critical deterioration event. The cascade doesn't even start. That's all she wrote. Okay, that's the whole thing. Now, I want you to notice something. Inspection is not on the list. Now, inspection is important so you know what's going on, but inspection itself does not defer failure. You can inspect it up the wazoo and it won't ever make a difference. It's like I have high cholesterol, right? Well, not anymore, but because I take drugs, but I have high cholesterol. If I take my blood every day, will I avoid getting a heart attack? No, because all it does is it says the cholesterol is too high, too high, too high. Inspection does not change failure. It'll tell you something's going on, but that's not enough. So why was this incident not detected? The railroad said that the hot box detectors were too far apart. Yet the one 20 miles before registered 105 above ambient. The employee tasked with monitoring did not initially see an alert that the bearing was starting to heat up. The video from a security camera 20 miles before the derailment showed the flames. Now, there's been engineering discussions about these hotbox detectors. So lots of people have been thinking about whether they're actually doing anything or not. I couldn't find any validation trials. I couldn't find any, like in the railroad journals and stuff. I couldn't find any of that. There was studies that showed that they weren't reliable, but not in a complete sense. Like nobody was looking at it globally. I say that the focus on the spacing of the hot box detector is a red herring because the goal of a good maintenance practice is to avoid the deterioration in the first place. So the hot box detector is telling us that we're not doing maintenance correctly in my world. So my question is, what does the railroad do to service, lubricate, and clean the wheel bearings? One would presume some kind of PM. We also know that heat is from friction. And in this case, I presume friction is from issues with lubrication, bearing damage, dirt, or all three. I couldn't find PM schedules for the rail cars. No one in the press asked about it. Now, I've written to some of the reporters asking them about this, saying, and to the national safety, the national NTSB. So but right now, the PMs on the rail cars are not public information, it seems to me. Now, there's something else going on that's driving all this stuff. Precision scheduled railroading. So Hunter Harrison developed a scheduling system while he was at Illinois Central. It focuses on moving the cars instead of waiting for a train to be built. The trains are always moving. The cars are picked up and dropped off, regardless of how long the train gets. As the trains continually move through the network, it balances itself, meaning the right resources like crews, cars, locomotives are where they're supposed to be when they're needed. So, with PSR, cars at the origin loaded first can be built and shipped with no waiting time. Listen, if you are from operations, this is like the holy grail of operations right here. So Norfolk Southern and other tier 1 railroads in the U.S. have adopted this. And for the first time in 75 years, the railroads are making money. And I don't have a problem with this. There was a talk, this guy, what was his name? Hunter Harrison. It's sort of sad because he went to Canadian Railroad and then he was hired away by CSX to do the same thing for them. And a month into the job, the poor guy passed away. So he never really got to enjoy the fruits of his cool thing. But his thing was he wanted the operating ratio to be below 60%. In other words, from every dollar revenue, 60% goes to costs and then 40% towards gross profit. Well, till he came along, the railroads were running with 90% costs. So you can just imagine people seeing that, whoa, this is a big difference. Now, our Oracle of Omaha bought a railroad when this happened, the Burlington Northern Railroad. So kind of interesting. Second thing, there isn't time or space in the yards to arrange the trains safely. So PRS, oh, I got that wrong. It should be PSR, encourages long trains. The trains are longer than the yards and they put new cars on the front. And this is the opposite of railroad best practice, which calls for the trains to be front loaded with the heaviest cars and the light ones in the back. Empty cars in the front make the trains less stable. The 32 ends load profile was 40% of the train's weight was in the rear half of the car of the thing, and the back half was heavier than the front half, which is the reverse of what you want. Now, under PSR, maintenance of the train is not even discussed. I would say it's neglected, but it didn't start out that way. What happened was they got these huge gains in performance. And if you're a boss, an operations boss, and you get a huge gain in performance, that is really great. You probably get a bonus. Everybody's patting you on the back. Everything is great. But what happens the next year or the next quarter? You still want more. You want more. And that's the psychological thing that happened. Norfolk Southern slashed number of employees over 25%. Employees reported there was no time or labor for proper maintenance. In fact, they got 60 to 90 seconds to inspect an entire rail car. This is not maintenance. This is inspection only. And remember, the rail cars are, 80 feet long. There's 4 wheel sets or 8 wheel sets. And they have to look at all this stuff in 60 to 90 seconds on both sides. We know that inspection does not stop or slow deterioration. PSR achieved unprecedented gains. It required local managers to hit targets for getting trains moving and sticking to schedules. Over time, the targets got worse, more stringent. Operating ratios got better, and the tension between efficiency and safety became untenable. So during 10 years, the number of maintenance workers at Norfolk Southern fell from 6,200 to 2,500. Now, I say with a tongue in cheek, the number of executives went down too, but it went from 1,900 to 1,700. So they got rid of what are we saying, 60% of their maintenance guys, and 10% of their bosses. And I mentioned this before, that the railroad industry is unique in the transportation because the trade group sets the standards. Now, this is an unverified, it was not verified by a major source. This was from a magazine that looks for dirt on things. But after PSR's implementation, Norfolk Southern employees said they're given a safety presentation by the companies, and the slides were our priorities: on-time performance, increasing train speed, reducing the duration of times in the yard, and safety was fourth. That was the safety presentation. Now, the safety experts at Norfolk Southern say PSR, I'm getting a problem with that, makes railroads safer. But you have to look at what's being claimed. It may be safer, but by some measurements, the incidents are much worse. Our Department of Transportation has registered 12,000 derailments over the past decade. 6,600 train cars are carrying hazardous materials, and 348 released their contents. And even though the safety experts at Norfolk Southern said it made the railroad safer, current numbers, the railroads derailments have increased from 0.65 per million miles to 0.75 in the latest period that they measured. So, statistics are easy to gen up, depending on what you want to look at. Now, random tidbit of information for our friends in Australia. The award for the longest train, 4.6 miles or 7 kilometers. WA, a BHP, Mount Newman Railway. It moved, it was a mine, and I don't know if it was iron ore or what, but it moved it 275 kilometers between Port Hedland and WA, and had a single driver. One person drove the train, 99,000 tons, 682 cars, with 8 locomotives. Oh, iron ore. So I thought that was fun. Never, they didn't have an accident, but of course their trains are. Every car is exactly the same weight, and um, it's the only thing on that rail is that train. Like there's not other things going on. So our obsolete rail cars, this is what we have: ineffective predictive maintenance, complex maintenance accountability, longer trains, no place to assemble them, 61% fewer maintainers, and less focus on safe assets, more focus on efficiency. Now, it's obvious that this is not just Norfolk Southern. Yesterday, there was an article, Union Pacific fired the track inspector because he wouldn't suppress his reports to the feds. So he was finding rotted rail ties. Screws were rusted off, and there was 18,000-ton trains running on this rail. So he ended up getting fired. But there's a happy end to the story. He sued Union Pacific, and he made a couple $1 million on this. But this is endemic. So profitability is the master corporate thinking. Precision scheduled railroading is a tool to increase efficiency. After the initial gains, they wanted more and more. But where could they get the gains? And that's where the problems wouldn't show up for a long time. So they slashed maintenance. Anybody that's been around for a while has experienced organizations looting their own assets to improve quarterly results and buoy up stock prices. So what does this mean? When a company operates a 1.7 mile long, 17,000 ton machine at 47 miles per hour, carrying hazardous materials within feet of houses, playgrounds, and people, I say they better make damn sure they prevent the deterioration and not just detect it. Personally, it pisses me off when they risk people for their KPIs and then cry the blues when the shit hits the fan, if you excuse that expression. This is very old fashioned. There's a promise to society that if you run a business, you agree to maintain the assets so the people, communities, and the environment are not harmed. And I want, guess what here? We are on the front line. We're fighting the good fight. We must fight the good fight, because if we don't, who will? So that's what I have to say about Norfolk Southern. Ian, do you want
Thank
to
you,
have
Joel.
questions?
Thank you, Joel. Yeah, I think there's a few there was a few comments early. There's a few comments earlier on which we can follow up on. But folks, I know we've come towards the end, but any quick questions for Joel? No? Any questions?
I'm reading these comments.
It's
And
just
Well,
more.
Joel, more of a comment
Go on.
rather than a question.
Yeah, I see
It's
that.
it's a sad observation. I work in the marine industry, and it's not dissimilar in the profitability statement over safety in some instances. And in regards to your earlier commentary there, yes, it's very easy to strip away maintenance for a short-term gain, but all that happens is you create a massive bow wave, and the piper has to be paid at some point in time.
Yep. I like that idea of a bow wave. And then how do they make money with so many derailments? Well, they're moving. We're having a banner year in oil from the Permian Basin and North Dakota and Texas and Pennsylvania. So they're not. There's nobody printing money fast enough for how much they're making money right now. And then without any expenses, except for the occasional $1 billion here, $1 billion there, it's pretty soon it'll get to be real money.
Okay, folks, thank you so much for being with us this morning. Just before you do leave, what we would love is for you to evaluate the session that you've heard and give your comments. In the chat, you will see there is just a segment there with a slight little survey. Should take you less than 30 seconds, literally. So if you please could comment on that, that would be fantastic. Remember to visit the community hub if you haven't already. We would all of the sessions that we have had, the masterclasses over the last couple of months are on there, as well as heaps of other very pertinent information. So please have a look at that as well. I want to thank you, Joel, for joining us from from Philadelphia, not Pennsylvania, this morning. Thank you, and I know that you're not feeling great, so I really appreciate that. With you struggling with the cold and that as well, so thank you so much. And folks, yeah, appreciate you being with us. We hope to see you very soon. And yeah, just before you go, just please evaluate with that session in that link. So have a great day wherever you are in the world, and we will see you very soon. Thanks a lot. Cheers, folks.
Thank you. Bye-bye.
Cheers. Are you staying on, Joe? No.